Section 8.3 is all about the area of circles and regular polygons. We'll start with the area of a circle. It's one that you might be familiar with, but it's one that's worth talking about where it came from. So if you take a circle and fold it in half, fold it in quarters, again, you fold it and fold it and fold it until you make this pie, all of these different pieces. If you were to cut up the pieces and rearrange them, you could make a parallelogram. Now, it would be kind of a lumpy parallelogram. But if you were to fold up the circle into more and more and more smaller pieces, the lumpy parallelogram would start to become a nice smooth rectangle. The dimensions of that rectangle are related to the circle. We see the height there would be the radius. The length would be half of the circumference of a circle. So the area of that rectangle, base times height, would be r times half of 2 pi r squared, or half of 2 pi. And if you simplify that, you get pi r squared. So a few examples with circles. Let's say in this example that we know the diameter and we want to find the area. Remember the area formula is pi r squared, and so the radius is 4. We know that the area, the exact area, you can say is 16 pi. Now that would be the exact area. If you wanted an approximate area, you could type in 16 times pi into your calculator. One last example with circles. Let's say that in a circle we know the area is 256 pi square meters, and we want to find the radius. So again, we'll set it up using the area formula. We'll sub in what we know, and we'll solve for what we don't. So we can divide both sides of the equation by pi. R squared equals 256, and so we'll square root both sides. The radius is 16 meters. Next, for the area of regular polygons, we have a few pieces of vocabulary to begin. So let's say we have this regular 7-sided polygon, a septagon. N will refer to the number of sides. P is the perimeter. S is one side length. And A refers to the apothem. Now the apothem is the line from the center of the regular polygon at right angle to the side. Right? It's the shortest distance outside. Make note the apothem doesn't go to the corner. It goes to the midpoint of a side. So language tip here. An apothem is again the line from the center of the polygon to its side. An apothem is a concise saying or aphorism. So for example, haste makes waste, don't burn your bridges, make it a great day or not, the choice is yours, are all apothegms. And then the geometry thing is an apothem. So why is that useful? Let's say we want to find the area of this regular pentagon. If you look at each of those triangles made up of the central angles, we know that there are 5 isosceles triangles. Now 5 isosceles triangles, and the dimensions, base and height, are the side length and apothem. Remember, the area of a triangle is 1/2 base times height. In other words, 1/2 times apothem times side length. And there are 5 of them, so the area of the regular polygon is 1/2 times apothem times side times number of sides. In this case, it's a 5-sided polygon, a pentagon. If we were to figure out a regular hexagon, it would be 1/2 times apothem times side length times 6. For a regular heptagon, it would be 1/2 times apothem times side length times 7. And so in general, we can say that the area is 1/2 ASN or 1/2 AP, where big A is the area, little a is the apothem, S is the side length, N is the number of sides, and P is the perimeter.